So when I learned a few years back that Mo Farhood was in our building and him and Charlie were talking down in the small animal imaging facility at MD Anderson about this machine called the Zera, it can do this cool sectioning. I was like, okay, I want to know a little bit more and see what's going on. So what they taught me was a term called CFT, Cryo-Fluorescence Tomography. This is the first I'd heard of it, but I pieced it together and I saw, okay. So these are a slide here, courtesy of Image, showing that CFT is an imaging technique which ultimately allows you to take these to perform serial sectioning of these animals, obtain these 2D fluorescence and white light images, and then you can reconstruct them and compile them to form really nice 3D images. So I was definitely intrigued by this because I thought it could add a lot of value to the work that we're doing. And I thought an image like this looks really cool compared to what we were generating. So we thought we'd give it a shot, and we were working with Charles Kinsley and then the group at Anderson Small Animal Imaging Facility. So our goal was to bridge our macro and microscopic findings with CFT, Cryo-Fluorescence Tomography. We also wanted to see what BioD would look like in an intact molecule. Ex vivo is cool. Ex vivo does not capture blood. We don't have that blood component. We don't have perfusion. So we're never going to be able to really wholly reconstruct a PET-like 3D rendering that actually has that anatomical context. And we thought we needed this to really, truly figure out what was the best agent. So here are just the steps for those of you that have done autoradiography before in the nuclear medicine or with radiochemistry. I did quite a bit of that. Here's a mouse injected with the compound, euthanized, and then embedded in an OCT block that's frozen. And then you mount this into the Zera, and then serial sections are performed. And then images are taken of those sections and then analyzed. And the way this all comes together, this is a CFT fly-through. This is one of the readouts that we have that we could show you. So this is going from the very top of the animal all the way through to the bottom. And on the left here, you have the IR800 first generation agent. And what you see with this is the yellow arrow designates the tumor that has SSTR2, where we see signal. But this is the wild type tumor. This is a tumor that is really a control, doesn't have the receptor. But you still see quite a bit of signal in addition to a strong overall background signal. But if you look here at the FNIR tag compound, you can see a very different biodistribution. Nice uptake in SSTR2 tumors, very low signal here, and essentially a clean background with the exception of clearance organs, which you see through the kidneys, and then some elimination that's happening through the gut. But all in all, I think this gave us a very nice indication of how the agent looks in a whole body format. And then we take that one step further here, and we got the really cool 3D reconstruction. So these are basically like our pet MIPS, and I love these images. And for me, this, images are worth 1,000 words, and I don't know if 3D images are worth 1,000 to the third or whatever the math might be. But I was really excited because, again, this really drives the point home of how much background signal we see due to the IR800 throughout the body, whereas the FNIR tag gives a very clean profile, nice tumor demarcation, and then just it designates, kidney high renal elimination.